Hello guys, in this video I'll explain you why yarn is required, why yarn came into picture. If you know about Hadoop1 architecture, it will be well and good. If you don't know Hadoop1 architecture, you can also watch this video. To more about Hadoop1 architecture, you can go through some Geek for Geeks articles. So today I'll explain you yarn. Before that, I'll explain you Hadoop1. What is the drawback in Hadoop1 so that we introduced yarn in Hadoop 2. So let's start. So yarn is yet another resource negotiator. Before going to the yarn, we will go to Hadoop 1. So in Hadoop 1, we have two perspectives: storage perspective and processing perspective. In storage perspective, we have storage perspective, storage perspective. We have HDFS, HDFS. Okay, we know that. So here there are two concepts in storage perspective. What is name node? One is name node. HDFS is Hadoop distributed file system. I hope you know that. So in architecture, if you see the architecture of Hadoop 1, we have two things called master. One is name node, one is data node. So how they are storing data in Hadoop 1? Okay. So they are called name node and name node and data node. Name node is a master. This is a master slave architecture. Name node is a master and this is slave. Okay. So what name node is doing? Name nodes is hold the metadata. Name node knows about all data stored in our cluster. Okay, you can say like that. It's know about the information where this data is, that block is present in which data node. So, name node keep information about data where is stored in which block, in which node. Those information name node holds. Okay, and data node actually store the data in terms of blocks. So data node is a actual data nodes where data is stored in terms of blocks. Actually we are storing data here in data node. Okay, so this is the storage perspective. Now if we go on to processing perspective, in processing we have in Hadoop 1, we have in HDFS, sorry, MapReduce. Hadoop 1 we have MapReduce 1. Okay, so processing perspective, we have what we have MapReduce 1. So we have MapReduce 1. This is the compute engine. Okay, so here also we have two things. Okay, one is job taker, one is task taker. Okay, so what is job taker, what is task taker? So this is also we called master slave architecture. So job taker is a master, task taker is a slave. Okay, so job tracker and task tracker. So task taker. Okay, this is the thing. Job taker, task taker. This is the master. This is slave. Okay, this is slave. This is master. So job taker used lot of work in MapReduce 1. It is do scheduling plus monitoring. Scheduling during, so if a job client submit job, so there are many jobs. Okay, to the client submit 2 3 jobs. So which jobs to execute first based on the scheduling algorithm it will decide. And priority, it will assign some priority to the jobs, and getting know the like to execute that job, is the resource available or not, and providing the, if it not, it will provide the resources to the job. So what actually do, it will do schedule also and monitoring also. Monitoring means tracking the progress of the job. If tasks fail, so it will try to reassign, it will try to like what I can say, if some tasks fail, it will try to start their task into another machine. Also if so if let's think we have 100 tasks and 99 tasks is completed, executed. One task is not executing, it is slow. So what this monitoring job tracker will do, it will start that tasks in another machine, and it will compare that if any task completed first, it will pick that. So job tracker what it will do? It is scheduling plus module. Scheduling means it will assign a priority to every task. Which tasks have to execute first. Also, it will provide resources to execute that job. Also, monitoring those jobs. If it is failed, then it will rerun that job. And if some if some job is slow, if task is slow, it will try to start that job in another machine based on speculative execution. It will try to like fetch those stuff. So if you're starting, let's see, if you have a one job, it is going on, so it is stuck at 99. So if we have a job one and job two, it is already started and it is taking too long time. Okay, it is taking a long time. So what job tracker will do? It will try to start this job. If this task is too slow, it will try to start this task job. It will try to start the tasks in another machine, and it will monitor both tasks, this one, whichever completed first, it will pick that. That's it, and remaining one job taker will discard that. So that is one scenario. So this is a job taker. It will do job taker is doing scheduling plus monitoring. So sorry, mm, it will do scheduling plus monitoring. It will do scheduling scheduling plus monitoring will be job taker. It will try to monitor the job, it is fail or not, it is succeed. So it will try to monitor everything, and scheduling, it will schedule the job and it will assign some priority to the job, which job will execute first. Simple as that. And if in one scenario, if one job is too slow, it will try to start that same job in another machine, and whichever is completed first, it will try to pick that, and remaining one will be discarded by job tracker. So what does stack stacker do? Stack stacker is a slave. So this stack stacker tracks the each data node and inform the job tracker. You know, we have data in our data node in term of blocks. Then track stacker is a main thing. We will execute the job. Okay, and it will try to monitor every data node. Okay, so in every data node we have a task stacker. Okay, it will try to execute the job, and it will try to give a feedback, give a information about those tasks to the job taker. So job taker will try to provide sorry task taker will try to provide information about tasks executing in data node, and provide the information to the job taker. So it will track the job. It will track each task in data node, because we have a data in data node where we will execute those data. We have a the track each task in data node and provide information about those tasks tasks about those tasks to to job taker. What type of information? if you think task tracker will try to give information, some information. What is that information? Information means that that task is executed how many percentage. So let's think they're executing on task. So it is nearly the task execution is completed nearby 70%. So it will task checker will do. So this much percent of this task is going on, and this much percentage already completed to execute, and this much percent remaining. So like this type of information task checker will try to provide to job tracker. So it will tell this task is going on expected. Otherwise, if some so it will give the state information of the tasks of the tasks uh, uh, to the job tracker. What in the like it will try to inform the state of this task to the job tracker. It is going on or it is failed or what is happening inside the execution. So execution information it will try to provide to the job tracker. That's one thing. So that's it here, and job tracker, task tracker, and name node and name node and data node. So I tried to give you one like you know like like basic understanding. I hope you should know those things. If you don't know, you have to go deep down in those things in Hadoop lecture. So if you don't know this Hadoop 1 architecture, I should recommend you go through some articles. That's it. Okay. So here I am trying to give you like basic idea why you are moving, why this EN is required. That's why I am giving this perspective. So if I show you the one architecture, what one type of diagram. So I'll show you one diagram. So here we have a job tracker. This is our job tracker. Job tracker, and we have client. Okay, so client will submit the job. Okay, client will submit the job, and then we have task tracker here. Task tracker. We have task tracker. We have task tracker. So what will happen when client submit the job tracker will schedule the job, and it will schedule the job in a it will schedule the job, and task tracker will try to execute the job in a data node. Okay. So we have in task tracker we have two type of jobs. One is called map tasks. One is called reduce tasks. Okay. So task tracker can be divided into two things: map task and reducer. Sorry, here I'll write map and reducer tasks. So client submitting job tracker scheduling those jobs, and task tracker try to execute the job and try to send information back to job tracker about those tasks. What is the condition? What is the execution condition about those tasks? It will try to send those information to the job tracker. And in task tracker we have two things: map tasks and reduce tasks. Okay. So I'll give one inform like so I'll try to give you one scenario. Okay. What is the actual like problem we are facing? Before that, I will tell you that like one job taker contain thousand of task taker. Okay. So I'll try to write these things. One job tracker contains thousand of task trackers. Okay. And what will and one task taker can hold thousand of jobs, and 10,000 of Map reduce tasks. Map and reduce tasks. Reduce. Okay. What I'm trying to say, if there is one job tagger, there can be inside that one job tagger, there can be multiple hundreds of tasks tagger. I will show this information. There can be one job tagger, there can be multiple task tagger, hundred of thousand of task tagger, and inside of one task tagger, there can be multiple hundred of map reduce tasks. There will be multiple of job. Okay. So inside of one job, there will be multiple task tagger. One is map. There can be one type of map task. There will be one type is called uh, reduce tasks. If you don't know about MapReduce, you have to go to Hadoop1 architecture and you try to understand what is MapReduce. Okay, I'll not explain here because this thing will take more time. I hope you know this. So if you're learning Spark, you know this what is map task, what is reduce task. This one if I want to give you. And due to this issue, we are facing we are facing one issue. Okay, so where there is a no job taker and lot of task taker, that is the problem in Hadoop. What I trying to say, if there is a one tax tracker, one job tracker, and lot of tax tracker, then it will be problematic in Hadoop one, as it is impossible to manage all those jobs by a one single job tracker. If you think there is a one job tracker and multi thousand of tax tracker, and so it will be like the job tracker will be overburdened with task. So that is the one problem, and to solve that problem, Ian come into picture. So problem is there is a one job taker and thousand of task taker, and to manage those task taker by a single job taker, it is impossible. That's why Ian come into picture. I'll give you one practical information about you, information of this. So what I can say, let's think we have a hundred, we have a one job, and in that job we have I will came into in this example later. Before that, I have to tell you what is the limitation of MapReduce we are finding able to find. So one is limitation of MapReduce. Limitation. Sorry. Uh, so first we will learn limitation. So limitation of MapReduce one. Okay. One is scalability. So it is observed when we have a cluster size beyond 4K data nodes. Then the job taker used to become a bottleneck. So let's think we have a one job tracker and a 4,000 task tracker. That time from that point it will try to the Hadoop1 architecture will face some problem. So that is one issue. The issue is scalability. Issue is scalability. Issue is scalability in Hadoop1 or MapReduce one. And second is resource utilization. So in Hadoop1 or a MapReduce one architecture, we have a fixed number of MapReduce tasks, and this is the problem. Okay, so we have a resource utilization problem. Okay, resource utilization. I will tell you why you are facing what will due to this resource utilization. Sorry. So one problem we are facing, resource utilization. Resource utilization. It means in MapReduce one, we have a fixed number of slots for map tags and reduce tags. So it means sorry, fixed number of slots for map and reduce task. Okay, map and reduce task. So you have a fixed number slot, and that is the problem. Why? Let's think we are trying to execute on job. Okay, in our system, let's think we have a fixed slot. Okay, we have a fixed slot 100 in our cluster. We have a fixed 100 reduced 100 slot book for reduce task, and 50 is allocated for map. So I'll reverse that. Okay, so sorry, so we have a 100, we have 50 reduce, and 150 map tasks. This is our system, and we fix this. Okay, in our cluster we have this 50 reduced tasks and 150 map reduce map tasks. So if client submit one job, okay, and in that job we have only we have 200 read map tasks, 200 map task. Then how will do it? If client submit a job with 200 map tasks, then how will do? How will MapReduce will execute those tasks? So in our cluster we have a 150, so we cannot execute a 200 tasks in one go. That we cannot do it. So what Hadoop will do, MapReduce 1 will do, it will try to execute first 150 tasks, then another 50 tasks. So it will try to do this execution in two steps. So first step it will try to execute 150 map task, because we don't have slots for 200. We fixed it. That we have only 150 tasks in our map tasks in our cluster. So it will that's why it will try to execute 150 tasks initially. Then it will, after the completion of this, it will try to execute remaining 50 map tasks. But if you observe, we have 50 reduced tasks, but we are not using it because we are already fixed that slots. So we are wasting resources if you observe this carefully. So we have a reduced tasks, but we cannot use this because we already fixed it. So that is called resource. That is called like we are not utilizing the resource in full potential. So we are wasting our resource. So that is the one problem here in MapReduce 1. And then, so we will summarize this thing. Okay, we'll summarize this thing. So whatever pain point in our MapReduce 1. So we have some pain points. Mainly we have a three or four pain points. So three pain point, I think three pain points. Pain points in MapReduce 1. So when I say MapReduce 1, you just think on Hadoop1, okay? Because MapReduce 1 come under Hadoop1. So 3 points in MapReduce 1. MP1, sorry, MR1. What is this? One is scalability. I already told you. Scalability. Second is less resource utilization, because we are already trying to fixed our resources. Okay, that is the that's why we are facing this issue, resource utilization issue. And third is in MapReduce 1 we can use only MapReduce engine. We cannot use Spark. Okay, so only 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 restrict it to MR jobs, MapReduce jobs. Okay, we cannot use another engine in MapReduce in Hadoop. So this is the pain point. These are the pain point why we introduce, why these Hadoop guys are introduced. Ian. So what is Ian? Ian is yet another resource negotiator. For, for this region, for the scalability, resource utilization, only restricted to MR jobs. For these three region, we introduced like MapReduce Ian architecture in Hadoop 2 architecture. In Ian, we introduce Ian in latest Hadoop architecture. So in next lecture we will try to learn about Ian, and now this weekend 15 minutes we have to stop it. So next lecture we will try to deep down in Ian. So thank you for watching this video. If you like my explanation, just hit the like and subscribe button. I know that there is some writing issue because there's some latency issue in Wi-Fi. So that's why I'm facing some delay. You can see some delay writing on screen and with my voice because due to some latency. So that's it in this video. In next video we'll try to understand Ian. See you in next video. Bye.